Welcome nerds, Horncode here, just your average coding little devil. Here again to explain to you geeks the most common coding interview questions that the big tech companies love to ask. And yes, even though these types of questions are as useful as an election day in Russia, these big tech companies love to ask these kind of questions. They love them as much as billionaires love space and Coke. In today's video, we will be reviewing another very common coding interview question. As common as COVID, the Maximum Contiguous Subarray problem. Now let's go to the problem description. Given an integer array of nums, find the contiguous subarray which has the largest sum and return its sum. A subarray is a contiguous part of an array that contains at least one number. Now, with the word contiguous, we are referring to the largest sum of numbers that you can sum up in a row from any subarray of the array. For example, here's an input we have -2, 3, 4, -1, 2, and -2. And as an output we should have 8. The explanation of this output is because the contiguous subarray 3, 4, -1, and 2 of this array has the largest sum, which is sum equal to 8. The best way to solve this problem is using the famous cadence algorithm. Now, there might be other less efficient ways to solve this problem, but why bother with those if they're not going to give us that 666 figure paying salary job? So the cadence algorithm is usually used to solve this kind of contiguous subarray problems, like for example the best time to buy and sell stocks algorithm problem, which basically is also a problem that goes over an array of contiguous stock prices and you get the maximum profit by choosing the lowest stock price in the array to buy and the highest stock price in the array to sell. Even though we already know that we should never, ever, under any circumstances, buy stocks high. You make poor decisions when you're high, like deciding to become a YouTuber. Now let's review how the cadence algorithm works. The cadence algorithm falls into the category of dynamic programming algorithms, which are almost always using two pointers. In this maximum contiguous subarray sum problem, we will be using these two pointers, current maximum ending at this index and the maximum of all. Now the way that we will use these two pointers is that we will traverse the array and update the values of those pointers. In the current maximum pointer, we will store the maximum of the contiguous subarray that has been summed up till this current index of the array that we are traversing. And in the maximum pointer, we will store the maximum of all the current maximum values we have calculated already in the array. So here are two of the formulas that we'll be using to calculate both of those pointers. Now let's traverse the array to see an example. At first, our 2 pointers will always start up being the first value of the array, in this case being -2. But then when we start traversing, the current maximum will always be the math max between the current maximum ending at this index plus the number on the index and the num index. So in the case of the second index, that would be the math max between -2 plus 3 or 3, and the result will be 3. And the maximum of all will be the maximum between -2 or 3, which is 3. And that is following this formula calling the math max between the maximum of all and the current maximum ending at this index. Then on our third index, our current maximum ending at this index will be the maximum between the sum of 3 plus 4 or 4, which will be, the result will be 3 plus 4, which is 7. And our maximum of all will be the maximum between 3 or 7, which will be 7. Then on our fourth index, our current maximum ending at this index will be the maximum between the sum of 7 plus -1 or -1, which will be 7 minus 1, which is 6. and our maximum fall will be the maximum between 7 or 6, which will be 7. And then on our fifth index, our current maximum ending at this index will be the maximum between the sum of 6 plus 2 or 2, which will be 6 plus 2, which is 8. And the maximum of fall will be the maximum between 7 and 8, which is 8. And then finally, on our last index, our current maximum ending at this index will be the maximum between the sum of 8 minus 2 or minus 2, which will be 8 minus 2, which is 6. And the maximum of all will be the sum between 8 and 6, which is 8. And 8 is the number that we will be returning. So basically, just to recap, all I did was traverse the array and apply these two formulas, and that at the end will give us the maximum of all on the pointers. Now, another important thing to mention is that this algorithm runs in O of n time complexity, because we are basically just traversing one time the whole list. Now, knowing this is important because those big tech company nerds love to ask this. Now, the implementation of this algorithm is so simple that even non-4i's should be able to implement this easily. So the first thing we'll do is we'll declare our two pointer variables that we said on our conceptual overview that we would need. The current max at this index, and we will set that equal to the first value on our array. And then also our max of all, which we will set that also equal to our first value in the array. And after that, all we have to do is start traversing each of the values in the array starting from the second index, because we already have the value of the element in the first index. And in our traversal, we'll just apply on each of our pointers the formulas that we saw on our conceptual overview, which in the case of the current max ending at this index was the maximum between the number that we are currently traversing and the current max plus the number that we are currently traversing. And in the case of our max of all, the formula was the max between the current max and the max of all. And after that, we will just have our max of all, and we'll just have to return our max of all. Now, let's test this. And there you go. As an input, we have our array, and as an output, we should have 8, which is the maximum number on a continuous subarray. So there you go. As easy as making money on OnlyFans. So please subscribe to this YouTube channel or follow me on horncode.com, because every 2 or 3 weeks I will be posting another one of these marvelous, fantastic, and mediocre video explanations. Buonasera!